Lagrange interpolation is a mathematical technique used to construct polynomial which passes through a given set of points, and this way is very useful in analysis and applied mathematics. First, we see the basis of Lagrange interpolation. Here's n plus 1 points. We write this as x0, x1, and x. And here's the basis of Lagrange interpolation formula. But look at this, there's no xi. And this is the formula, and this is xi. And example L2x is x minus x0 multiply x minus x1 over x2 minus x0 multiply x0 minus x1. And here's the formula of Lagrange interpolation. And write this formula f at I is the value of the function of xi. Lix is the basis of Lagrange interpolation. And have the example L2x is this f at 0 L0x plus f at 1 L1x plus f at 2 L2x. Okay, let's do the example. Find a degree to polynomial f(x) such that f minus 2 is 3, f1 is 4, and f2 is 7. First, we must find the basis of Lagrange interpolation. L0x is x minus x1 multiply x minus x2 over x0 minus x1 multiply x0 minus x2, and x0 is this minus 2, x1 is 1, x2 is 2. So that we write this as x minus 1 multiply x minus 2 over minus 2 minus 1 and minus 2 minus 2. This is 12. So this is equal to x minus 1 multiply x minus 2 over 12. And L1x, L2x is the same. This is x plus 2 multiply x minus 2 over minus 3. And L2x is x plus 2 x minus 1 over 4. The last process is to find the fx. Fx is 3. No, this is 2, and this is I is 0. If si lis, so that fx0 is 3. This is 3 multiply x minus 1, x minus 2 over 12, f minus 1 is 4. This is plug 4 modify this otherwise there's no space to write, and this is I5 2 is 7, so third plug 7 L2x. This is the degree 2 phenomenal f(x). Another example. Find the degree 3 phenomenal f(x) such that f minus 2 is minus 3, f minus 1 is 2, f1 is 5, and f2 is 7. First we must to find the basis of Lagrange interpolation. L0 is x minus x1, x minus x2, x minus x3 over I0 minus x1, I0 minus x2, x0 minus x3. I'm not going to do it here, so I go with the final result. This is x plus 1, x minus 1, x minus 2 over minus 12, and Ly and Ly and Ly is L2x, L3x is the same as and this final result is x plus 2, x minus 1, x minus 2 over this. This is L2x is x plus 2, x plus 1, x minus 2 over minus this, and x L3x is x plus 2, x plus 1, x minus 1 over 12. This is the basis of Lagrange interpolation, and we must find the f(x). So f(x) is this. The degree is 3, so this is 3. I is 0. I and this is I minus I. Now I is, and this is the basis. I minus 2 is minus 3. F minus 1 is 2. F1 is 5, and F2 is 7. So we put this into this formula. We get f(x). Okay. Next, here's the error calculation formula of Lagrange interpolation, and this is the formula. If f(x) is n plus 1 times differentiable on a closed interval a to b, the error at a point x is given by this formula, and this is a value in a to b. Let's see the example. There have this and we only see this expression, not interpolation phenomenon. We give the Lagrange interpolation is this, and his real phenomenon is this guy, and the third here have two derivative, and we must to find the third derivative, and there is it reaches its maximum value at x is 1.6. Let's take the derivative of fx with x is 1.6, and this is the value. E2x is the arrow bound. E2x is here is x is 1.4. Okay, this is 1.4. This is 1.4. This is 1.4, and this equal to this equal to this is less than this value. Actual value error is f1 f1.4 minus p2 1.4 is this value. So this is actual error, and this is the error bound. Okay, I see this last example. Let n be a positive integer, and this we can find f0 is 2, fi is 2i plus 1, and we should find f1 plus 1, and if we can define gis is fx minus 2x minus 1, and because of fi is 2i plus 1 for 1 to n, so gx is 0, but gx is 0 to 1 to n. Okay, so we can write this as fx minus 1, x minus 2, x minus n. Okay, gx is this, and g0 is minus 1 power n modify this and c. Okay, and this is equal to f0 minus 1 is 1. C is this, right? And fx is gx per 2x per 1, and this equal to, let's say, put this into this. Okay, this is full, and part 2 x part 1 if n part 1 is put n plus 1 into this, okay? And this is the thing we need to do, and this is finished.